Or 80 on page 444, section 5.1. Gives us a word problem here. Talks about the circumference of the Earth. The Greek mathematician, that guy, measured the circumference of the Earth in 200 BC, which is pretty impressive. He noticed that on a certain day, the sun shone directly down a deep well in Syene. So basically, he could tell that the sun was perfectly overhead because it would shine straight down in a well. And the only way that could happen is if it was perfectly overhead. So that was here. And then, at the same time, in Alexandria, 500 miles north, on the same meridian. So it's kind of important that you're, well, we don't need to get into the physics of it. If we just take the cross-section, this is a good picture. But 500 miles north, the angle that the sun's rays made with the horizontal, with the vertical was 7.2, okay, per degrees. He used this information to find the radius and circumference of the Earth. So he actually used this to find the radius and circumference of the Earth. So we want to find the radius here. If I just draw a bigger picture, I basically have, some unknown radius, and I know this arc is 500 miles. And because of, just some simple geometry, if we have parallel lines, the sun's coming from a long ways away, so these lines are pretty much parallel, cut by a transversal, then these angles are the same. So basically, this is 7.2 degrees. So that's it. I want the radius, I know the central angle, and I know the arc length. The angle is equal to the arc length divided by the radius, or the arc length is equal to the angle times the radius. However, that angle needs to be in radians. So, the arc length is theta, 7.2 degrees. However, I got to convert that into radians. So I'm going to multiply by pi over 180 degrees. So that's my theta times the radius, which is, I guess, unknown. In this problem here, the arc length is actually known to be 500. So put 500 for the S, put this in for theta, and solve it for R. So R is equal to, I don't really want to do any of this in my head, so I'm going to go 500 times 180, the degrees cancel. 180 is a number, divided by 7.2 pi. So that would be R in exact form. As an approximation, I'm going to pause this while I do it. So to find the approximation, you just put this in your calculator, which I just did. 500 times 180 divided by 7.2 pi. Enter. 3,978.9. We'll go to the nearest mile. By the way, sig figs are all shot because our degree is only to 2 decimal places, so we should probably round this to 4,000, but 3,979. 3,979, miles. So that's approximately one answer. And the second part said find the circumference. Well, that's just 2 pi r. So 2 pi times that last answer gives me about, crazy how close that is to 2,500 off. That'd be, so the circumference is about 25,000 miles. Okay?